Hi, welcome to Finite Pi Videos. This is DC here. In this video, I'm going to show you how to use the page protection feature of the ICODE SLIX tag. In fact, the reason of switching from the earlier versions of ICODE like SLI or SLIX to this is because in SLIX2 you have this the page protection feature. I did mention about this in my earlier videos very briefly, or maybe it's messed up with other features discussion as well. But this video is going to be dedicated to just this page protection feature, and it's very essential that you understand this very well, and you know what this page protection feature can and cannot do. These are some of the highlights of this page protection feature. Now blocks, we know that every 4 byte in the ICODE SLIX or SLIX2 tag, it's called as a block. Now you know there are around 70 or 80 blocks in total. The block number starts from 0 to 79. So this is the background you must be aware of already from my previous videos. Now these blocks can be protected with a read password and a write password. Now this is called as a protection bits. So you can have a read password and a separate write password. This protection bits or this protection feature applies to the block number 0 to 78. The last block, that's a block 79, is the counter block, and this protection does not apply to the counter block. In my previous video I did show you how the counter block works, and counter block has got its own protection bits for read and write. This protection can be completely locked and forever. So what this means is the protection bits, that is whether it is whether the read password is required or write password is required, once this is configured you can lock, so nobody can remove the read password or nobody can remove the write password. So this is called locking the protection bits. Now in order to use the read protection, you have to first, the way the read protection works is, if the block is read protected, you have to first send the read password before any read and write. So you have, if the block has got only the read password, then you can still write it, but however for writing it's still controlled or protected by the read password. Now if the block is set to use a write password, you have to first send the write password before any write operations can be done. So you can have both read password and write password, or you can have a combination of that. Say assume that you got a read password and the write password. If nothing is set, anytime anybody can go and read and write or change the block. If only the read password is set, now before you do any read operation you must set the read password, and before you do any write operation you're still going to use the same read password. So here in this combination, a single read password controls both the read and the write operation. If I got only the write password enabled, then read is allowed anytime. You can read without any password, anybody can read, but in order to write you have to send the write password. You can have both read and write. Now both are two different passwords. When it's configured with both read and write password, for read operations you are going to use the read password, for write operations you're going to write password. I'm going to show you how all this protection bit works, and after that probably you'll be very good in this concept. There's also interesting feature which probably if you're a developer will be interesting for you. This entire memory block can be divided into two segments. Now this is like having multiple applications in a single tag. So when you divide, you're going to have two segments, the segment L, that's a lower address segment, and the segment H, the higher address segment. So the segments are called as segment L and segment H. Now in order to divide that, you're going to use what is called as a page pointer. The page pointer divides the memory into lower and upper. Now what exactly it means is, think this is the memory of SLIX2. You have to ignore the counter block. Counter block is nothing to do with, is not part of any paging. So the counter block here I'm not going to consider at all. Okay. Now you got the block number 0 up to block number 78. Now if the page pointer, if that is set to say for block number 20, what we have done is everything from 20 up to 78, they all belong to the segment H. Anything from 0 to 19, it's considered to be part of the segment L. Now when for a brand new tag, the value of the page pointer is always set to 0. So it means every blocks from block address 0 to 78, they all belong to the page H, because the page pointer is the one that divides the memory into two parts. Anything page pointer value and down is the higher segment. Anything from page pointer up is a low segment. It's as simple as that. Okay. Now this is the theory. Okay, you have to first understand. So next I'm going to show you now. I'm going to take probably a brand new tag, and I'm going to show you how all these features work. So if you open the SLIX2 documentation and you go to the section 9.5.3.6, all the things I've just mentioned and what you're going to see now, it's very well explained. So I would advise you to go through this reading, at least once. And here I'm not going to probably now speak about this command structure, because we have discussed this command structure a number of times in my previous videos. So there are two parts here. One is how the page production works. Next thing about how to log the page production. So it's just two sections you have to read and understand. Now you can see I have connected my Arduino and the PN580 board. It doesn't matter whether this or there's one more parallel series going on where I showed you how to use this ICODE SLIX tag with the OmniKey 5022 reader writer. So it doesn't matter, it's the concept remains the same. So I'm going to keep a brand new SLIX2 tags. So I'm going to activate this, and I'm going to bring all the page data into this software. Now what the software has done is, now it has started to show an additional column called the page column, which for a brand new tag, as I mentioned before, all the blocks belongs to the same segment, the H, and the last block, that's the counter block, does not belong to any paging. If you look into this NXP system information and click on a get, the page production address, this is the one that divides the memory into two parts, is set to 0. So anything from block 0, including block 0, downwards belongs to page H. Anything above that, in this case nothing above that, belongs to page L. And also, since this is the brand new tag, you can see all the default values here. You have to understand the page protection conditions. This section you have to understand, because this is related to what we're discussing now. So here it says, it tells you what is the current value of this page protection. It says page L. The read password protection is no. The write password protection is no. It means both read and write protection are not enabled for the lower page, and for higher page also both read and write are not enabled. So that means I can go to any blocks and start reading. In fact, we have already read it without any password protection. And also we can write. I can go and modify. So go to page 2. I'm going to modify this into a random number. I'm going to write. Now write is successful. So we are able to do both read and write without any password. So next is start applying this protection. Best thing is I would like to change the password. This is a brand new tag. The password is always zeros for read and write password, and it is value 0f for privacy and destroy, which I'm going to talk about this in my future videos. I'm going to set this first you have to authenticate. You have to first send the old password before you change. Set. Okay, in order to do that, you must always have the address mode. Set the password, and I'm going to change it to 1. Then I'm going to set the right password first. See, before what I'm doing here is, before you can change the password, you have to first send the original, the known password, which is zeros, and I'm going to change this to 2. Right, so I have changed the password from default to 1 and 2. So I'm going to reactivate this tag. Click on get. So to get the block numbers and say read. So we are still able to read, and you can see the status is still that. So let's play with the read and write password without doing any segmentation here. Now this section here called page protection is what you will be using. A couple of things you have to keep in mind before you make any changes for the page protection. You must first set the read and the write password. The tag should know that you already know the read and write password. Let's get that. Get the random number, send the read password, or we'll try to do that without sending the read and write and see what happens. That's the best way to learn as well. So I have not authenticated so far. It was we still had a zeros there here. Now I'm going to apply a read password, or say write password for H. See, I know that all these blocks now belong to page H. So there's no effect of page L here. I'm going to say, I'm going to write protect page H. Now if you try to write, now you will get an error message. This is very obvious because the datasheet says you must authenticate both read and write. I'm going to just do just the first one. I'm just going to authenticate a read password. Set address mode. Set. Let's try to make a change now. Right, error because the tag needs both read and write password sending. Authenticate with the right password. Set. Now make a change. So I'm not going to change the start page address here. I'm just going to keep everything as it is. Just apply the write protection page here. Write protection for all this segment H. So write. Now we are able to, you got a success message, say page protect, okay. So I'm going to take this tag out, authenticate, get the system information, you can see what changes has gone in. Say get. Now because we are write password is enabled, you can see this is set to yes. I'm going to make a change to the page 03, and remember we are trying to change without first setting the right password. Say W, you got a right error. It's very obvious because you have to first send the password. So to get the password, get the random number. The right password is 2. Set it. Address mode. Set this. Okay. Now you try to write. Now write is successful. So try doing this is something for page block 4 as well. So the right password is already set. You can go and write any block you want. Say W, write is successful. So this shows that how to use the right password. So next, play with the read password. Now to make any changes for the page protection, you're going to work in this section, and this section will you can change only with both read and write password set. So far we have got only the right password set. I'm going to send the read password also. Set. Now the tag knows both read and write password are sent. Now you can make a changes here. I think the software should have, what this software should have done is it should have showed you a tick here. So this is the one, isn't it? We had write protect. Okay. So I'm going to do both read and write protect. Right. Now it's done. And instead of taking the tag out, we'll try to work with this RF off. So RF off, then probably now just try open that again. So RF on, activate, system get, read entire block. Now you can see that the Arduino is trying to transfer something, and what you should see is only the counter block, because we have just protected both read and the write operator. In fact, I know this is taking more time. It's because of the error messages. Look at that. So the software says could not read all blocks. However, it can read the block 79. Now this is exactly what the documentation says. The counter block is not part of this segmentation. It's not part of the page H. So in order to read, what first thing we have to do is we have to first assume that I just want to read. You have to first send the read password. Set. Now if you hit read, okay, you're able to read it. Look at that. So you have to do the read, set the read password before reading. Now you still can't make any changes here because it's right password protected as well. If you go to the system and say what the current state is, you can see that for page H both read and write password are protected. So go back here, set this write password. Sorry, we are about to make changes here. So write is an error. Now go and change or set the write password. Now try to write it. The write is successful. Look at that. So we just learned how to protect with the read password and how to write password. Next thing you're going to say how to divide this memory into two segments. One is the lower segment and upper segment. Now assume that where you need for example there are so many. You can ask why do you need two segments. Okay, there's so many applications. One of the applications could be, say, assume that you got two completely different applications, one for your transportation and one for your internal payment. Now I can have the first 40 blocks for the transportation application and the next 40 blocks for the payment application. That's one of the thing. Or it could be, say for example, a single application where the top section, the lower page is where you keep all the customer information, customer details, and the highest segment probably can keep all the transactions like all the purchases, or if it's a library application, probably you could record all the books that are checked out, and so the top section is completely read only, nobody can modify without the read password, whereas the bottom thing, the segment H is writable but with the right password. Now you can still do something like this, with the locking. If I lock these pages, those pages will become read only forever. So you got a combination of features here. You got the block locking feature, plus you got a paging feature with its own read and write password. It all depends on how you design the system. So the main thing here is understand what this feature is, then you can utilize to whatever way you want. So I'm going to divide this into two, say from 30. Now my start page H starts from 30 and above. We are dividing, so everything from 30 and below is page H, and 0 to 29 is page L. Say, the thing is here, you have to be careful. Okay, everything here goes as a single write operation. So we already protected this and this. Assume that I don't want to protect the page L. Not now, we are going to do that soon. Right now page protection is changed. Okay, now the problem here is because the software is not syncing these values with these two takes. It's a bit of a confusion now. So if you are written without taking these two, you are literally removing the read and write protection. So probably this will be fixed in the later versions. Now I'm going to reactivate this tag. Now let's try to read. Let's think what's going to happen if you hit the read. We have the page L, the top page is completely readable, but the bottom page, the page H, is protected with the read password. So in theory you should see the block 0 to 29 followed by the counter block. Now look at that, block 0 to block 29, because this belongs to, there's something wrong here. I think this should have gone to, this should be showing as a page L, but not H. This could be a software bug, so that needs fixing. So this followed by the counter block. Now because it's the top block, I can go and modify. You can write it, there is no protection at all. However, let's go and see what this thing says. So this says the page protection address set to 30, and both page L and page H, they're not protected. Oh, look at that, now there's something has happened here. So this could be a small glitch in the software. Now it is showing they all belong to page L. However, the software is showing the counter belongs to page H, which is wrong. Okay, so this will be fixed in the next version, maybe 2.6.1. So we have got a page L. Now to bring the value of all the blocks in page H, I have to first authenticate with the read password in address mode, the read password. Then if I go and hit read now, you should get all 80 blocks, and hope the software shows both L and H. Look at that. Okay, so the software now shows 0 to page 29 belongs to page L, and block 30 to the, not this one, still not happy with that. Okay, till here belong to page H, but not this thing. This should be blank. Now there's some information here as well. It says in RW, it means these blocks are both read and write protected. That makes a bit sense here. This goes with the what is shown here. So that's something good to have on the screen. Now I'm going to do the same thing for the page. Let's set, so whenever you make a change to this section, after that you have to match the start page should match whatever is set here. Now assume that I want to keep the page H both read and write protected. However, only apply the read protection for page L. Now before you make any changes this section, you must have both read and the write password set. So I'm going to say write. Oh, there's something wrong. Yeah. So what I just did was I just clicked on R&D again and send both read and the write password, and then I'm going to hit this write. So now the page protection is changed. So if you go back, I'm going to reactivate again. Sorry, not required. Go to get and read. So because both page L and page H are read protected now, we are not able to read anything. If you go to an XP system and hit the get, you can see that the page L is read protected as well as page H. So first thing we do is set the read password, and there's only one single read password for both page L and page H. Keep that in mind, that you don't have two read passwords. So if I try to make change for this the top page 07 07 07 07, so I can make the change. That it's just that you don't need a write password, because the top page, the page L, is only protected with a single password, whereas the bottom page is protected with both read and write, two separate passwords. So you need write password for writing and read password for reading, whereas in the top page, because it's set to only the read password, just a single password is enough. Now this is also a nice feature to remember. So if you just need one password for everything, probably can use that. Now last thing I'm going to do is just lock everything. Now before you do the changes, you must have both read and write. Set write password. Okay, there's an error. Oh sorry, this was set to 2. Yeah, one thing you remember here, whenever you get an error while setting the password, you have to reactivate the tag. So either you turn off this RF off and you activate and you get here and you start all over again, get a new password. Does it work? No. Looks like the software is not ready for that. Just start from the beginning. Probably it was because the RF was not on after that. Okay, get, and I'm going to send both the read password in the address mode, send both read password, send both write password. Okay, and I think I mentioned something wrong before. I'm going to correct that now. Now, is it possible to change this the page protection pointer? It is possible. Okay, you just have to go and change. If you see right now, it is the page pointer set to 30, and I think you don't have to match this number while writing. I'll tell you when the start page should match. The start page should match to the lock operation, not using that. Assume that I change my mind and I want a bigger page size. I want the page size, the page L to be 40 blocks. So the page head to be 40 blocks and the page L to be the remaining 30 blocks. Okay, if I want to do that, Now I still want to keep everything as it is. Now this time I'm going to protect both. So right, now everything's protected. If you go and hit the read here, probably the read still shows the old flag. However, if you go and hit the get operation, probably system resyncs itself. If you look at that now the page head starts from 40. What we did just now is we just changed the value of the protection page address. Earlier it was 30, now we made as a 40. Now that's it. Now next thing is we are going to lock it. We are going to freeze this thing. Our password is set. We are going to freeze this configuration, and nobody can ever change this configuration. Now before hitting the lock, I'm going to send you that this should match. Try without matching that and try to lock. Now you got an error. This error is because if you read the documentation again, now during the time of locking, the start page should match whatever it was set on the tag. It was 40. If you hit a lock, look at that. Now the lock is your configuration is locked. Now nobody can change the read. Nobody can remove this read and write protection. However, you can still go and change your password. That's a different thing. Changing password or locking password is different from locking the configuration. Now let's try to change the configuration and see whether it works for us. Now I know both are read protected now. I'm going to first send the read, and I'm going to send the write password. Now hit this read. Sorry, before you do that, hit here. Okay, now we'll try to change the configuration. If you look at the value of this PP conditions, everything is set to yes. Go back here and assume that we want to remove everything. Okay, maybe right here. Let's say it's error. So you can't change the configuration once it's locked. So I think this covers the entire concept of page protection and page segmentation, and everything you need to know about the page protection. Okay, thanks for watching.